Hello, I'm Tarek, and in this video I will teach you about velocity and displacement as an application of derivatives. So as a start, let's review instantaneous rate of change, also written as IROC, and average rate of change, written as AROC. Now, instantaneous rate of change is the slope of tangent line, and it can be found through deriving a given function and substituting a specific point where the rate is being calculated. So for example, let's say we have the given function fx equal to x squared, and you want to find the instantaneous rate of change at x equals 2. All you'd have to do is first derive the function. Derivative of fx is going to be 2x, and then substitute the given point into the derived function here, and then you'd get 2 times 2 is equal to 4. As for average rate of change, you can also say it as the rise over run if you want. It would be y2 minus y1 over x2 minus x1. This would give you the average rate of change. So this was a quick review for IROC and AROC, so that when we later on move to displacement and velocity, you don't find any difficulties understanding the topic. Now for the main topic, displacement and velocity. We'll start by defining displacement. Displacement is the distance traveled over time by an object. It is a vector. It can be positive or negative, and it can be given through the notation st. Velocity is defined as the rate of displacement with respect to time. It is also a vector, so it can be positive or negative. It's given through the notation vt. Now, there are two types of velocity: average velocity and instantaneous velocity. So, going back on the review which I posted on my previous video, average rate of change is found just the exact same way as average velocity, y2 minus y1 over x2 minus x1. And instantaneous velocity is found through the derivation of the displacement, since it is the rate of displacement. So if you derive that to get the st, the derived form, that is equivalent to the instantaneous velocity at a certain point in time. Now if I draw a quick graph here, let's say here y equals 4, y equals 2, and x equals 5, and draw a line from here to here. Now we want to find the average velocity. All you have to do is get the y1, x1, which would be x1 is 0, 1 equals 0, y1 equals 2, then x2 equals 5, and y2 equals 4. Plug them into this equation, you get 4 minus 2 divided by 5 minus 0 should give you 2 over 5. This will be your average velocity. Instantaneous velocity, just as an instantaneous rate of change, you can find the example in the previous video on how we derived it to find the instantaneous rate of change. Now we will move on to describing graphs and how to move from displacement time graphs to velocity time graphs.